So you probably have heard people say that numbers don't lie, and then they use math and statistics to back up their points, usually to try to convince you of something or to sell you something, basically to get your money. But the fact are that many people manipulate numbers, and they only show you what they want you to see to help prove a point. Therefore, it's very important to have a good understanding of what they're showing you, but more importantly, to ask questions about what they're showing you to avoid being deceived. So in this video, we're going to look at two simple measures of statistics that most people know about, in the mean and the range. We looked at the mean last week, and everybody should really know what the range is. So a lot of times we look at these and we teach and learn these separately, but it's actually pretty important to look at them together. So when someone tells you the average of something, then you'll be able to ask the right questions and understand, whether it's valid, meaning like you know it, you can trust it, and you can believe in it. So let's take a look at the types of questions that you're going to see today, and try to make sense of why it's important to look at the mean and the range at the same time. First couple questions we're going to look at deals with the range. So we're looking for the range of the data set, and when you're looking at the range, what you're really looking for is what is the maximum minus the minimum. Maximum being the highest number and the minimum being the lowest number. So when we look at this data set, 50, 52, 36, 46, 41, 36, 56, and 65, which is talking about college graduates and the number of hours that they work each week. What we're going to do is identify the highest number, or the maximum, which is the very last one. So there's our max. And then our minimum, I'm looking through here and I see 36. And it doesn't matter how many times 36 appears, it's the lowest number that we have. So in order to find the range, we would take that 65 minus 36 and get 29. So I'm going to go ahead and put in 29 for the answer here. So it's as simple as that. Range is just look at the highest number minus the smallest number. And that's what this question is as well. So I'm just looking for the highest number in this data set, which is 86. And the lowest one is 67. So that has a difference of 19 when you subtract them. So that's how we find the range. So let's jump into another type of question. All right. So this type of question, as mentioned earlier, we're going to start looking at the mean and the range at the same time. Mean is commonly known in the real world as average, and people throw average at you a lot when they're trying to prove points. Like the average of this is so and so, the average of that is so and so, like the average salary of something, to try to give you a general idea of something, and usually to try to convince you of some things. So for each class here, there are 4 different classes. They give us a range and they give us a mean. So why is it important to look at these together? And really what we have to consider is, if the range is huge, that means that these scores are really, really spread out, and you can't really trust. It almost means not necessarily that there could be an outlier, but they're so spread out that you can't really generalize them with one number. And that's why it's important to look at the range and the mean for both of these. Now, these types of questions are really only just asking separately, like what has the biggest or smallest range, which has the biggest or smallest average. And when it says what class has the most variability, we've talked about the word vary. Vary means to change. We've looked at, variables. We put letters in for numbers and we call them variables because it may not necessarily be one, so it can change. So we say what has the most variability, that means which ones have the numbers that are the farthest apart or have the biggest spread, and that's exactly what range is. Range talks about how spread out the numbers are. So we just have to look at right here the range of scores for each one. Class B has the largest range, so they have the most variability here. All right, and then B, based on the information above, which class has the highest scores on average? So average is another word for mean. So the highest average goes to class D. So we're looking at B and D here for our answers. We'll look at another one like that before moving on. So same idea. We've got the mean age of a bunch of different teams and then their ranges as well. So part A says which team has the least variability here. All right, so just kind of pointing out what we're talking about. The least variability means which one has the smallest range. So we look at the range of all of these teams. The smallest range is team C. And then part B says which one has the oldest members on average. So once again, we want the highest mean, and the highest mean goes to team B. So we got team C has the least variability and team B has the oldest team on average. So just putting those answers in. All right, now let's get into the questions of, what do these really mean here? Okay. What do they mean? No pun intended. So 3 students want to estimate the mean backpack weight of their schoolmates. To do this, they randomly choose 4 schoolmates and weigh their backpacks. So they're going out and getting some data. They're taking samples here. All right, a sample is when you're looking at just a small group, think about it, it would be impossible to go around and ask every single person. Maybe not impossible, it would take way too long, more time than anybody wants you to ask the weight of everybody's backpack. So they take something called a sample, which is just a small portion, and you hope that you get that to be representative. All right, so the first one, the sample mean, we just have to add all of these numbers up and divide by however many there are to find the mean. All right, we looked at that before. So for number 1, we're taking 7 plus 8 plus 9, and there are 4 of them, so we would divide it by 4. So that's going to give us 31 divided by 4, and that is 7.75 there for the first one. Number 2, they actually have the same exact numbers, just in different orders. So it's still 7, 7, 8, and 9. So that's also going to add up to 41 or 31 and give us an average of 7.75. The last one is going to be slightly different here. So we would do 8 plus 9 plus 8 plus 5. And once again, there's only 4 of them, so we would divide them by 4. So 8 and 9 is 17. And then another 13, that gives us 30 divided by 4, so that's going to be 7.5. All right, so I'm going to go through here and fill those in real quick. So sample mean, 7.75, 7.75, and 7.5. Now, here's where this gets interesting. The range of the sample means. So the range here, the highest is 7.75, the lowest is 7.5. So the range of those is only 0.25. So only a quarter of a pound. So what does that mean? All right, if it's only a quarter of a pound, that means there's not a lot of variability. All right. If these sample means, say one was 10, one was 2, one was 15, all right, that means there's a lot of variability and you can't really trust this average. You can't really trust the mean, all right, because it's all over the place. But the fact that most of these sample means are all very similar to each other, we can totally trust this. And that's what we're talking about here. So let me bring my marker up to point some things out here. So it says the mean of the sample mean tend to be a worse estimate than a single sample mean. So what they're talking about here, the mean of sample means like the average of the average. All right. And that's actually a better thing to do, because if you took just one single sample, all right, that may not be representative of the larger population. All right. So if you're trying to, and just think of it this way. If you wanted to know about 100 people, but you only asked 4 people, all right, that's not really representative of the population. All right, so the more people you ask, the better. So if you ask 4 people in one class and 4 people in another class and 4 people in another class, that is definitely going to give you a better idea of what the population is like. So the mean of the sample means, that will be a better estimate. So this one right here, this is not good. We don't want to do that. That says it's actually worse. The next question says, a single sample mean will tend to be a worse estimate than the mean of the sample means. That one's true. All right. So that's a good one, because once again, a single sample mean isn't taking into consideration as many people. So the more the better. The closer the range of the sample mean is to 0, the more confident they can be in their estimate. And that's the point I've been trying to make throughout this whole idea, is if that range is close to 0, that means things aren't spread out, that almost everything is identical to each other. Things are very similar, so you can trust that mean. There's not a lot of outliers out there. Everything is pretty much the same. So that's definitely true that we want to select. And then we get the exact opposite. The farther the range of the sample means is from 0, the more confident they can be in their estimate. No way. All right. That means more things are spread out, and that's when you can't trust the mean. So we're looking at, if someone's giving you, oh, the mean of this is so-and-so, ask, okay, well, what's the range of their information? And if they tell you that the range is a large number, then you say, well, maybe the mean isn't the best thing for you guys to be using. All right, so let's go ahead and select these two. Oh, I got yelled at because I didn't put a 0.25. I apologize, Alex. So let's go through and look at another one. I'm going to use the calculator real quick to get my averages. All right, so 6 plus 6 plus 9 plus 3 plus 7. I want to show you a common error here. All right, so there are 5 questions here. So we can divide by 5. But notice if I put all of these add all of these numbers up and then divide by 5, order of operations say do division before addition, and this is not what we want to have happen. All right, if we try to add them all up and just divide by 5 without using parentheses, the only thing that is getting divided by 5 is 7. All right, and that gives us 25.4, and you can see that's not representative of the numbers at all. So you have 2 options here. One, add all of these numbers up and hit equals first, like this, so we get 31, and then we can take that 31 divided by 5 and get 6.2. That seems a lot better. Or the other thing is use parentheses. So 6 plus 9, the 3, and the 7. So to make sure that we add all those up first, obviously order of operations does whatever is in parentheses first, and then divide by 5. We get the same answer, 6.2. So just a common mistake that a lot of people make. But just think about what you're doing also. If you had an answer in the 20s and the highest number you get is 9, obviously that's not going to be correct. So the next one, I'm going to average 9, 7, 4, 5, and 6. So I'm going to total that up first before I divide. And 31 divided by 5. Oh, didn't mean to do that. 31 divided by 5. Same thing we just had before, 6.2. So right now it's seeming like the sample averages are all very similar. So this looks to be some pretty trustworthy data here. All right, let's check the last amount here. So clear this calculator. 8, 5, 7, 8, and 4. Total that up, I get 32, and 32 divided by 5, 6.4. So all of these are very similar to each other. There's not a lot of variability here. Everything is all very close to each other. Range, I'm just taking the highest minus the lowest, so 6.4 minus 6.2. And be careful when we're talking about the range of the sample means. All right, we're not looking at the range of all of the data points. Like the highest is 9, the lowest is 3. We're not looking at that range. We're looking at the range of the sample means, of the 6.2, the 6.2, and the 6.4, and that gives us just 0.2. Which means that we can trust these. That these are pretty valid results because everything is pretty close together. So going through part C, just go one by one for the true statements. The closer the range of the sample mean is to 0, we should be more confident, not less confident. So that one's incorrect. The farther the range of the sample mean is from 0, the less confident they can be in their estimate. That one's the true one. Because that means that there is a lot of variability, so you can't trust that. And then once again, the mean of the sample means gives us the better estimate than just a single sample. The more, the better when it comes to statistics. All right, so just staying on this page real quick to tell you a little bit about your assignment. This is just a preview of your assignment. It is in ALEKS again. As you can see, the name of it is going to be Interpret Means and Ranges. All right, so we're looking at, what does it mean when you put these things together? All right, so if there is a small range for the sample of means, you can trust it. All right, it's a pretty good estimate. If there's a large range between your sample and means, then you don't really want to trust that. And as you can see, there are 10 questions on this, going to be worth 10 points. So good luck with this assignment. If you have any questions, go ahead and Zoom with me during your class time or during my office hours. Good luck.